Accelerated Math Analysis. We're doing day 2 of section 10.3, which is on ellipses. We're going to have to graph and name pertinent information for this equation. You can see it's not in vertex form. It's not all factored. So here's what we need to do. We're going to look at our y terms and factor out the leading coefficient. Factoring is really undistributing, so that's really dividing. So I'm dividing everything I just circled by 9. You can always double check if you're right by redistributing the 9 in. For my x's here, I'm going to do really the same thing. I'm going to factor out a 4. I'll have x squared plus 2x. I'm also going to move that 49 to the other side. I'm going to move that to the right. And when you change sides, you change signs. Well, you might have guessed why we're doing this. We're doing this to complete the square. And completing the square will always focus in on the linear term, on the term that does not have a squared variable, but just a variable to the first power. So what we're going to do is take half of that. We're going to include the negative if need be. 1/2 of -6 is -3. I'm going to put a star by that. We're not done seeing that. And over here for my other parenthesis, I'm going to take 1/2 of a 2, and half of 2 is a 1. I'm going to put a star over here. The reason why we put those stars is because we're not done seeing those numbers just yet. What you'll always do is square then what you just starred. -3 squared equals 9. So that's what I'm going to add inside of the parentheses. I'm going to say a plus 9. Now it's so tempting to look here and to think that I should add a 9 to the right side, because what you do to the left side you should do to the right side. But please understand, we factored that other 9 outside. So really, if I redistributed that, you could see that the new term that would come up on the left side is 81. So I'm going to have to say plus 81 here. As I'm completing the square for this other problem, 1/2 of 2 is 1. I'm going to square the 1 to just get a 1. I'm going to put a plus 1 in here. It sure looks like I added a 1 to the left side. However, 4 is distributed to everything in the parentheses. What you're really dealing with is a plus 4. Now it doesn't take too long to see on the right side, and we can even get some help. Oopsie daisies. 1 second. Okay, sorry for that little technology glitch. You can see everything on the right side quickly adds up actually to 36. So we're closer. We're definitely closer. This first parenthesis, if you remember the starred term, it's -3, so this is going to factor into y minus 3 quantity squared. I've got my 4 right here, but you're going to notice that I put a star at a 1. This would be x plus 1 quantity squared. And it's right here where we can definitely realize what's going on. We don't have the equation of the ellipse with 1 on the right. So tell you what, let's divide everything by 36 so that we will get a 1 on the right side. 9 goes into 36 4 times. 4 goes into 36 9 times. And then you have a much nicer, very much nicer looking ellipse. Your center is going to be at, well, look at x files, -1 for the x, it's x plus 1, then a +3. And you know, you could even begin to start graphing that. You could say, okay, I'm going to go 1 step to the left and go 1, 2, 3 steps up. Hopefully you can see that our bigger denominator is underneath x. So we're actually going to have major axis that goes horizontally. I'm going to go 3 steps to the right of this center. So I'll go 1, 2, 3, and that's at 2, 3. That's a vertex. And then I'm going to go, of course, with my x direction 3 steps to the left. So I'll go 1, 2, 3. That's going to be over here at -4. So this will be at -4, 3. So those are your vertices. Unfortunately, you don't get symmetry here with a plus minus, but that's okay. You might wonder, what about down below? The semi-minor axis is a 2, so we can go up 2 steps from the center and down 2 steps from the center, and that's going to get you your ellipse. Now, of course, there's still something missing. We're going to need to know that, yeah, a squared is equal to 9. We know that b squared is equal to 4. We need to find c. So you might remember we were using a squared equals b squared plus c squared. A squared, you could say it's 3 squared, but at the end of the day, you already know what a squared is. It's 9. B squared, that whole thing is a 4. And you can subtract a 4 from both sides, and you'll get c squared is equal to 5. Take your square roots, and you'd get c is equal to radical 5. That's your focal distance. Now, your focal distance is going to be, the square root of 4 is 2. Square root of 5 is going to have to be just a little bit bigger. So what you can do to plot your foci, and you do want to plot your foci, go from your center and go 2 and a little bit more for your foci. And we'll go 2 to the left, we'll go 1, 2, and then just a little bit more. That's your other foci, but you want to name it. Well, this is where we can use a plus minus with some symmetry. You can see my center was -1, 3. If I'm moving right or left, I'm affecting the x coordinates. And I'm going to add radical 5 and subtract radical 5. So the way we can do that very cleverly is just to write it like that. Okay, well, hopefully this made some sense. You're going to have some problems worked out with the sub, or some problems that are assigned, and then you can get started on them. Good luck.